we can apply the disk method to scenarios where there is a hole in the disk. But this has a special name. It's called the washer method. And a washer is basically an item that goes on the end of a bolt in order to secure it. And it has a hole in it so it can fit over the bolt. And it looks kind of like this in 2D. Right? So it's got that hole, and that's what a washer looks like. It looks almost like a donut. Right? It's got that hole right there in the middle. So the idea is, well, if I'm going to find the volume using this method, there's going to be a hole in the middle. How do I find the area? Well, if I was going to find the area of this, I would set the area up as pi times this big radius squared would give me the area of the whole thing. So pi big R squared, and then I would subtract the area of the hole. So pi little r squared. Now, you can write this, and you should write this, as big R squared times little r squared, because the pi is basically a greatest common factor at this point that I could factor out. What you're going to be tempted to do, which you can't do, is tell me that this is pi and then big R minus little r all squared. That is black magic at its finest. This, when you multiply this out, that would require foiling, and that is not equivalent to this at all. So please be careful with that. Let's go ahead and write our formulas down. When we go volume around a horizontal axis, remember that's kind of our normal orientation that we're used to. So we're going to put the pi on the outside. Always got to be careful with the pi. We're going to integrate from a to b. And then we're going to have big R of x, which represents the larger radius, minus little r of x. And each of those are squared individually. So big R of x squared minus little r of x squared. Now, obviously, when we do change of orientation, we're going to be dealing with y's, but it's going to be a very similar setup. So we're going to say big R of y squared minus little r of y squared dy. So you're going to have to subtract the smaller of the two radiuses so that you can create that hole, that gap. Now, a couple of things to remember, pretty basic right here. Whenever we talk about disk and washer method, the rectangle is what is perpendicular to the axis of revolution. So that's how we get our radius. Our radius is always going to be perpendicular to the axis of revolution. And if the representative rectangle is vertical, we're going to work with x's, right? That's our dx scenario. And if it's horizontal, we're going to work with y's. So there is a change of orientation possible that we're just going to have to be careful with. Now let's go through our steps. We're going to do the same general steps that we talked about with cross sections. Number one will always be to determine dx or dy. So determine if using dx or dy. And that really has to do with what the radius is perpendicular to in terms of what your axis of revolution is. So what's the axis of revolution is a good question to kind of ask yourself when trying to determine this. The second thing is we want to find the limits of integration. So those two are the same steps for both. Okay, so limits of integration, and that often involves intersections. Because we already have an area formula for these, it's pi r squared, so we know that part, but we've got to be able to set up the integral accurately. So our third step is going to be to identify, and this is a big one, identify your big R, and if necessary, and little r. Now, if it's not a washer, this is for washer only. If it's not a washer, you're only going to have one radius. But if there's a washer method, you're going to have a big R and a little r. How we find that is really important, you guys. So we want to pay attention to this. In order to get that, you always want to take the distance from the function to the axis of revolution. Function to axis of revolution. Well, how do we find that distance? This is where top minus bottom or right minus left comes into play. That's how you're going to find a distance between two functions, top minus bottom or right minus left. So identify big R and little r, and then all you need to do is set up the integral. So number 4 would be find the volume, right, using, and then let's go ahead and set this up. We've got pi integral from a to b, and then we do big R squared minus little r squared dx, right? Or if it was a change of orientation, we do pi c to d, big R squared minus little r squared dy. Keep in mind, and this may seem like a silly thing to have to write, but it is always the big volume minus the little volume. Your volume's not going to be negative here. So make sure that you have identified the larger radius and the smaller radius accurately. And we want to make sure that we get a squared on each one of these individually for us to be able to get this in our calculator accurately.